One of the main discussion points when deciding between a traditional fixed-wing and VTOL-capable fixed-wing drone is the takeoff and landing. It is often said that the VTOL drone can take off and land anywhere, and that by using VTOLs you can get the best of both worlds with safer takeoffs and landings, plus the longer range of a fixed-wing drone. But is this the whole story? There are a few points to consider here. Firstly, the wind. Often this is not fully explained on the specification sheet, and VTOL drones can often suffer when taking off in stronger wind conditions due to the aerodynamics of such a system. Additional motors and propellers, and bigger and additional control surfaces are required to be able to take off and land, and all of these things significantly impact the aerodynamics of a drone. As a result of this, in windy conditions, VTOL drones can suffer and can end up being either unable to take off at all or can require significantly more space than is normally needed. This can eventually result in more space being needed than a fixed-wing drone like the EBX. Another point that is often mentioned is that vertical landings are safer than belly landings, meaning less damage for each flight. Again though, there are some other points to consider. For example, if the drone does not land perfectly straight, the potential for damage is considerably higher. That damage can be quite significant on a complex and heavy VTOL drone, whereas with the EBX, it was designed from the ground up to be capable of handling those belly landings over and over again, regardless of the terrain. Lastly, another point to consider is operating altitude. VTOL drones can often have a hard time with the takeoff and landing when the project altitude gets higher, in the mountains of South America for example. Some other drone manufacturers have had to resort to using modified propellers in order to handle the lower air density, and as a result of this, and the lower air pressure, the battery consumption, and therefore flight time, can suffer significantly.
My name is Michael Blake. I'm part of the SenseFly product management team. I've been at SenseFly for 4.5 years. Hybrid systems are impressive in their capabilities in terms of payload carrying and also flight performance. It is, however, not completely true that they can take off and land wherever they want to. VTOL systems often do require sustainable clearances for landing zones and also takeoff to accommodate outside factors. So what are these outside factors? Wind gusts being one of these factors, or even turbulence that cause this type of common issue near obstacles, trees, buildings, etc., which can be very dangerous for VTOL type of units. As a result, a buffer is needed, usually within the excursion zone of the landing and takeoff, to add the safety element factor for this type of operation. Additionally, near obstacles, GPS signals can be impeded, causing positional errors that can increase the buffer zone needed for further operational landings and takeoff. Examples was at Intergeo in 2019, a leading VTOL demonstrator was unable to perform safe landings and takeoff within the defined takeoff and landing zone. At the same time, the EBX was able to conduct multiple flights and demonstrations within the same area under the exact same conditions as this VTOL drone was given to operate within. Another point to consider as well is the weight. Most VTOL drones differ between 4 to 8 kilos in weight, and then therefore are substitutes to different regulation factors. This can also have significant considerations as well when pushing towards aviation authorities in terms of operational near airports, or talking about beyond visual line of sight. Yes, this is something that's been brought up by a lot of our customers over the years. The EBX is our 5th generation of fixed-wing mapping drone. We have learned many lessons from our customers who are operating in all around the world in different types of climates and environments, from stony to rocky, from hot to cold environments. These types of lessons have then accumulated into now what is the EBX design. For example, the underbody skin of the EBX is made of ruggedized polypropylene fiber composite, making it incredibly strong and robust to handle all these types of landing environments. For over 10 years now, Untitled Drones have been conducting belly landings, meaning hundreds of thousands of flights all over the world. We've since one day focused on safe and lightweight mapping drones, which are critical for belly landing operations. For example, one of our customers was involved in some emergency mapping missions after the bombing of Beirut. Conditions were naturally very difficult and the terrain was very rough. Despite this, the EBX was able to land safely and successfully over many flights. It is difficult to say the exact area that you need to land, as it really varies from system to system between a VTOL or a fixed-wing drone. However, it is a common misconception that a fixed wing always needs more space to land. For example, one comparable VTOL drone requires an area of 30 meters diameter for a clear landing, compared to the EBX, which also needs a 30-meter clear zone for landing, or even less with a steep landing functionality within our emotion flight planning software. It is true that the approach path it can be limited by the directional for landing due to the wind and obstacles. However, the EBX is capable of landing with a safe crosswind from anything from 6 to 7 meters per second. Going back again for the example with InterGeo, this clear example was a situation where the EBX had sufficient space and was able to land safely, whereas the comparable VTOL drone alternative was not able to operate successfully within the parameters given to us. Again, this varies from drone to drone. It's difficult to say in the broad sense, but VTOL drones are necessarily more complex, which often leads to more difficult and expensive repairs. For example, the EBX has 3 moving components, where a traditional VTOL would have 4 to 6 to 8 moving components, which magnitude increases the risk of failure. Most VTOL drone manufacturers are in the early stages of setting up their support and service networks, so this infrastructure is still being built in the background. Again, this can lead to more expensive and long delays due to shipping logistics. From an end user experience, we know these kinds of delays are critical as it deeply affects the deadlines and operational sustainability for the end clients. Additionally, more current VTOL drones are built to try and combat aerodynamics and constraints. As a result, they often sacrifice the reliability of the airframe. This further complicates repairs and means you can end up replacing an entire center body for a simple crack or damaged piece on the drone. In other words, surveyors in the field usually cannot simply repair the drone on site, which leads to more shipping, logistics, and overall delays for the end product. With 10 years of experience and 5 generations of drones, the EBX itself was designed around the feedback from our end customers and users to be able to develop a drone which can be quickly and easily repairable in situ. We know accidents happen and we want to ensure the fastest possible turnaround for all our customers on site. With the EBX modular design, this means that even if the drone has to go to a service center, the repairs and the turnaround should be extremely fast. In a practical case, 1 day. We have over 85 service centers globally and first-class support network that can help you get flying quickly as soon as possible. To help us with this, many parts of the drone are serviceable in the field by the end user. For example, the wings, pitot tube, vertical surfaces, etc. We focus on the modularity design for our end customers, as it is critical that deadlines are met and that the drone can be repaired as fast as possible. Not all flights are done in nice conditions. We understand users don't always have the perfect conditions to fly in and will sometimes need to fly in locations that are difficult for any drone to fly in. Simply put, the aerodynamics of any flying system, whether it be fixed wing or helicopter, suffer in high altitude and high temperature conditions. Without getting into too deep, this is caused by a lower atmospheric pressure and affects everything from a DJI Mavic all the way to a Boeing 747. That said, rotary systems, whether it be helicopter, VTOL drones or multirotors, suffer even more. Typically, the solution to this aerodynamic problem is more airflow. So for a fixed-wing drone, you simply fly faster, which is relatively easy to do. For a rotary system, this means motors all have to run harder, faster, decrease efficiency, and also the battery life. Once again, the added weight and complex aerodynamics of a VTOL can compound this issue. What this means for the end user is that mapping in tougher conditions such as high altitude or high temperatures can be extremely difficult or potentially not possible with a standard commercial VTOL system. This affects all users who consider flying in tougher conditions around any mountainous terrain or any hotter desert environments. For example, the mines in South America, some of which are above 4,000 meters in altitude, flying a Vtol drone can require special hardware changes and suffer reduced flight times.
Vtol drones are a fantastic new development in the drone space, but like most new technologies, there are key advantages and disadvantages. It is really important to understand these points when deciding on which drone you should buy. For example, the drone you buy should fit the types of projects you are primarily working on. A sports car is an amazing piece of engineering, but it would make a terrible survey vehicle due to the lack of storage space and poor handling of rough terrain. Vtol drones have the advantage of being able to take off and land vertically, but this comes at the expense of size, weight, and complexity. To make a drone hover requires a huge amount of energy, and as a result, Vtol drones require bigger and more powerful motors, which require bigger and heavier batteries. This in turn adds more weight, requiring a stronger, tougher body, and even again, bigger and more powerful motors. What this means in practice is that to achieve the same flight time and coverage, a Vtol fixed-wing needs to be significantly bigger, heavier, and more mechanically complex than a comparable traditional fixed-wing. These things need to be considered when planning your battery management, site access, and ongoing maintenance. For example, when traveling into the field, how many batteries do you need to bring? How will you charge them? How much equipment will you need to carry? And how will you transport it to the mission site?
Hi, my name is Benjamin Pinguet. I'm a product manager and I've been working at SenseFly for 7 years. So Vtol drones are heavier by design. Vtol is a type of drone where they try to combine the capability of vertical takeoff while keeping the capability and efficiency of a fixed wing. So they had to do compromise and they had to integrate more hardware in their drone, like extra engine, more servo, more flight controllers, some even have landing gears. So you have a lot more weight to start from. So therefore, you have like a catch-22 loop where you try to get efficiency, and you try to have this good sensor, but you keep gaining weight to be able to do that vertical and landing part. So therefore, you have a system that is more complex and is heavier by design. So in terms of efficiency, how much coverage you can achieve, you can notice that Vtol and EBX have similar capability. So it's really down to the weight. The EBX weight about 1.3 kilogram, whereas Vtol can go up to 4 to 5 kilogram. So this is a huge difference between the two, especially when the weight is an important consideration for your operation. Another aspect is the vertical takeoff and landing phases. So the Vtol require a lot of energy during these phases, and this can have a significant impact on the efficiency you can achieve. And this is even more true in difficult environment conditions. So if you're on high altitude, if you have high temperature, or if the wind is strong, this is going to affect even more your efficiency. So with the EBX system, we've created the drone system that is very easy to use. So first of all, you only need 3 minutes to assemble the drone, install the battery and the payload, and be ready to fly. It's not necessarily the case with Vtol system, where you have more complexity, more assembly time, so you have more physical activity to do to be ready to fly. Looking at the software, it's also a very important element of your efficiency. With eMotion, you know you're going to have the best-in-class flight planning software with 10 years of experience. We've put in there the right tools, the right capability, while keeping a simple and easy to use interface. If you need to be even more efficient, eMotion can offer the capability to do multiple drone flight, so you can multiply, double, triple your flight efficiency while still being safe. Following the data capture, you have the post-flight step, which is just as important as the data capture. So with eMotion again here, what we've done is that we have an entire workflow that really is simple. So you can just take the SD card out of the drone after the flight. If you are using PPK, the images are already geotagged, so you can start your processing straight away. And for the PPK processing, it's also integrated in eMotion, so you have one interface from data capture to start off your processing. Last point is about field repair. So as you know, rough landing can happen, and the EBX is a system that is easy to replace, that has the capability to be replaced and repaired on site. So you can simply swap a wing, you can tape also if necessary to be able to finish the job, because you might not have the opportunity to come and finish it another day. Okay, so the first thing to consider is how are you going to access the site. So with the EBX, you have a system that fits inside a backpack. That means you can operate your drone even from a remote access area easily. You don't have heavy cases, multiple cases to carry around, and that can be a huge advantage. A point to consider is also the amount of equipment to carry. Vtol typically require to have 2 batteries per flight. So the logistic involved in doing a very large-scale mission can be tremendous with a Vtol. You need to multiply the number of battery and charger and things to carry around. With the EBX, you have much more flexibility and a much more transportable system. Also, you always need to have some spare with you when you're going to fly. You might need to do some small repairs, swap on the field. And with the size of the EB, you can easily carry all the necessary equipment with you that fit into a small box. We heard about an extreme example where a customer, when he moved to a Vtol system, needed to purchase a new field vehicle in order to fit all the extra cases required for the system. Another point is the reliability of the data. I mean, it happened to all of us. We go to the field, we complete the mission, we take all the images, and then we realize there was something wrong with the camera. Or even worse, sometimes you find it out when you're back in the office. So it's really important to have a system that have a full hand, full controllability on the payload. And the Vtol system typically integrate off-the-shelf camera. That means they do not have a full control on the payload. SenseFly used to do that in the past also to use a shelf camera, but now we've moved to a more integrated camera. This means we have full control of the pictures. We know when the payload is working or not. We can ensure all the pictures are taken. We can ensure that the geotagging is functioning correctly. So therefore, when the drone lands, you know that you have all the data you need. Software is a key part of the EBX system. And many customers tell us that what triggered the decision to go for a SenseFly product is the capability of eMotion. And we have 10 years of development and 1 million flights to back it up. So first of all, we have a fully featured software. And we've built that really from customer feedback. I can give you the example. A month ago, a customer came to us having the idea to improve the efficiency of the tilting soda, to really do one line corridor and be able to perform more type of mission. And this sounded interesting for us, and we've been able to develop that feature in just a month, so the customer can get more of the system. And that's exactly what the flexibility we have with eMotion. We completely own the software, it's a custom design, it's designed at Sensefly, and therefore we can optimize every bit of it. It's also true for the firmware and the other element of the drone. Speaking about, for example, the Autopilot, most of the systems use open source ecosystem, which means they do not have full control of all the elements. It means also that they are not optimized for the element they use. So they might save some development time at the beginning, but they cannot achieve the same level of integration and efficiency we obtain at Sensefly, having a full control of the entire ecosystem. And if you look at other companies, for example, Apple, it's exactly what they are doing as well. They control everything from the battery, the processor, the element, the firmware and software, and therefore they are also able to offer to their customer an ecosystem that is coherent from beginning to the end. So the question you need to ask yourself before choosing a system, a Vtol or fixed wing, is what is your typical flight scenario you're going to be into? So ask yourself about what are the space available at the area where you're going to operate the drone. Is it limited? Is it open? That's an important point to consider. And Vtol can provide a solution in the situation where space is very limited. However, there's also more point to consider, like the environmental condition. Is it a very windy location? Is it at high altitude? And also, very importantly, what are the regulations at the area you're going to operate the drone? This can have a very strict limitation on the system you would be able to operate. So this can reduce the advantages of the Vtol can offer. In all other scenarios, consider the pros and cons as discussed today. So the weight of the system, the payload capability, the ease of use, the repairability. So with the EB, we have a lot of great advantages there, as mentioned. And choosing a Vtol also have its advantages, but think about all the elements you might be giving up choosing this type of system.
As previously mentioned, Vtol drones are generally bigger and heavier by nature. There is also the question of ongoing performance and maintenance when compared to a smaller and lighter traditional fixed wing such as the EBX. As a result of this, traditional fixed-wing drones have a much easier time getting approvals from civil aviation authorities, such as BVLOS, or a less restrictive category for the incoming EU regulations. As much as drone manufacturers like to say that drones do not crash, the reality is accidents do happen, and aviation authorities, insurance companies, and risk analysts know this. A simple, lightweight drone will always have an easier regulatory path than a larger, more complex one. So, if you don't need the sports car for its top speed, you should always consider if it's worth the downsides. Another point that is often noted for Vtol drones is that they are typically bigger to begin with. They are also often paired with larger, higher resolution cameras. This is undoubtedly a positive sounding point, but a higher resolution camera does not necessarily translate to better quality, better coverage, or even better efficiency. In fact, the majority of competitor drones are using off-the-shelf cameras, and while these cameras are fantastic cameras, they are designed for photographers and not photogrammetrists. The result of this is additional weight from the extra unused parts of the camera, heavy lenses that are optimized for general photography rather than photogrammetry, and cameras that are not as integrated with the drone's autopilot. All of this results in a loss of overall efficiency when looking at flights within the typical allowed flight altitudes. Additionally, while these photos might look great on their own, the additional size and quantity required can result in a less efficient overall process and can also cause errors with the processing, such as a failure to match tie points or even a failure to reconstruct the dataset. Hi there, so my name is Christopher Thompson. I'm the Global Sales Manager here at Sensefly in Switzerland. I've been here for 7 years, 7 fantastic years, and I'm here to give an insight into the regulatory side, both in Europe and globally. Sure, so Sensefly's philosophy has always been small, lightweight and sub 2 kilo drones. One of the main reasons for this is that our drones are designed for safety, ease of use, and of course the ever-changing regulatory situation, not only here in Europe but globally. We've been around for 10 years, as you know, and during this time we've collaborated with many distributors, and we have distributors in all 4 corners of the world. And so they help us as well to make sure that our drones are compliant not only for now, but also with an eye on the future. To give some examples on the BVLOS operations we're doing, which really stretches the regulatory side of things with our drones. We're doing extensive testing within Europe. We have the right to fly over Italian cities with our EB Classic, one of our older generation drones. And both in Canada and in Brazil, we have waivers to perform BVLOS operations. So we continue to do what we can do within the regulatory side of things, but we're continuously operating with our global network to make sure we get to the next level for ourselves and for our clients. Well, drones are becoming increasingly more and more used in all industries: surveying, disaster management, agriculture, anywhere that needs on-demand data. And it's not just our key markets, it's in general, and it's global, where regulatory side of things are having an impact with the use of drones. We think it's critical to ensure that our drones are also easy to use, but also easy to manage from a legal perspective. So we work closely with our own distribution and our own in-house experts and regulatory bodies around the world to be able to help influence the regulation in different countries. And we really want our clients to be able to use the full potential of the technology. And so this goes hand in hand with the expertise of Sensefly, the expertise of our network, and the expertise of local regulatory bodies. Absolutely. We see people following regulation all over the world. There are people obviously that try to avoid it in certain circumstances. They can be critical when people do this though, and we've seen this in many different countries where people try to circumvent the regulatory side of things when it comes to drones, which are moving objects in the air, so they can be dangerous for, you know, flying over objects, flying over people. We've seen clients that have lost their projects, maybe even their business, as a result of not following the proper guidelines. So the thing that's most important to Sensefly and our network, and especially our end users, is the education surrounding these changing regulatory side of things, because what might be relevant one day might not be relevant the next. So I guess what we make sure ourselves and our global distribution are focused on is keeping tabs on the ever-changing side of things and making sure that our end users that are operating in all 4 corners of the world are kept up to date with that side of things. So firstly, we have an in-house regulatory expert. He's been working closely with the EASA, and he's working in an advisory role to help define sensible and usable drone regulations for our users. Each European country before these regulations had different drone regulations, which made it difficult for cross-border usage and collaboration. So these regulations are meant to have a universal approach for the European drone users. The new European drone regulation came into effect on January 1st of this year, which marked the beginning of a transition period. So during this period, all of our drones fall into the A2 category, which is the A2 limited open category. And so this is capped at 2 kilos. And as I said before, that's our philosophy, is sub 2 kilo drones. And this allows all of our users to operate very similar to how they were using the drones before. As soon as the C rating is available, which is when certifying labs will open, which is not currently, we'll update our global user base on the path to become compliant. And the EBX drone is expected to fall into the A2 category, which means in terms of usage and operations, closer proximity and higher risk operations than using heavier drones. So it's a real key selling point to our system, and again why we focus on these sub 2 kilo drones. And lastly, I'd say we're developing very simple guidelines and kind of FAQs and helping our users navigate this complex process so that if they want to do these more complex and BVLOS operations, we and our distribution are there to help them. So in certain category drone operations, these may become complex and often bureaucratic, a lot of paperwork and a lot of things that people aren't used to navigating. So being compliant and having the correct documentation is going to give users an edge over their competitors and will make their drone operations a lot more simple. And so this is why it's really important to SenseFly and our network being able to empower our end users to make a potentially difficult procedure very easy. Technology is always ahead of regulation. I think we've seen that over the past 10 years. And so having an advanced system that is as compliant as possible can have a huge impact on the economics of a project. And so having guidance on how to unlock the full potential of your system, such as the EBX, and being able to do operations like BVLOS, this can save our users thousands of dollars, both in the permissions that they'll have to pay for or apply for, but also their day-to-day operations. They can do a job in an afternoon as opposed to 2 or 3 days. So essentially it all comes down to size and weight. As I mentioned before, we're focused on smaller and lighter systems, whereas a Vtol system is typically bigger and heavier. And we've seen also that this is a major impact within the new EU drone regulations. So it's worth noting that the regulatory bodies have preferences for smaller and lighter drones when it comes to making decisions. Another point to make is Vtol is a relatively new technology, and so when it comes to historic data and proven safety records, there's usually limited data available, which is often key and a key requirement for regulatory bodies when they make decisions moving forward. So SenseFly's been in the drone industry for over 10 years. It has tons of global data, safety records, BVLOS approvals, flying over cities. So we're in very much a better situation when it comes to this historic data and proven capabilities. Vtol has its uses for sure, there's no doubting that. However, from a regulatory standpoint, there are still many, many challenges for it to overcome moving forward. So several things, both here in Europe and globally. So to recap what we've said today, the C certification for the European regulations. As soon as we're able to move forward with the labs and the certification, we'll be looking to do accordingly. We're working continuously with our in-house experts, our distribution and our end users and key accounts to help BVLOS applications and operations. So again, here in Europe and globally around the world. Continuous collaborations with the regulatory bodies like the EASA, the FAA and many more. And there are many more things to come that unfortunately today I cannot share, but please watch this space and I'm very much looking forward to sharing you those when I can.
Hola a todos, mi nombre es José María Marchetti, yo soy el manager regional para Latinoamérica de SenseFly. Estamos acá con la gente de Geocom de Chile, nuestro distribuidor oficial en el territorio. Un gusto tenerte con nosotros, Óscar Moreno. Óscar es un gran experto en drones, trabaja con Geocom como ingeniero de aplicaciones desde 2014 y ha pasado por muchas etapas dentro de la empresa trabajando con diferentes marcas, ¿cierto, Óscar? Ahora vamos a aprovechar todo ese conocimiento tuyo y realmente queremos empezar haciéndote algunas preguntas como fundamentalmente cuándo empezaron, cómo fue ese tiempo de transitar los primeros drones de ala fija que ustedes comercializaron, con toda esa experiencia, cómo fueron esos primeros años.
Hola José, un gusto reunirnos con ustedes. Sí, la verdad nosotros desde el año 2013 estamos trabajando con sistemas aéreos no tripulados, en ese entonces solamente de ala fija, y claro, fue un periodo de aprendizaje bastante importante, con hartas pruebas, errores y aprendizaje, todo eso. Partimos y hemos ido evolucionando a lo largo de los años, trabajando con diferentes marcas, como tú bien dices. Por lo tanto, hemos recapitulado y hemos adquirido mucha experiencia en todos estos años.
Seguro. Y bueno, en ese tránsito de las distintas marcas que ustedes utilizaron, que sabemos que empezaron trabajando con drones de ala fija, con los primeros que hubo en el mercado, y en algún momento también comercializaron importantes marcas de drones Vtol, de despegue y aterrizaje vertical. Cuéntanos cómo fue esa experiencia con los drones de despegue y aterrizaje vertical.
Sí, efectivamente, trabajamos alrededor de 2 a 3 años con equipos Vtol. Fue una buena experiencia. En realidad la operación es muy similar a los equipos de ala fija en términos de planificación de vuelo. Claro, si uno tuviese que hacer una comparativa entre ambos, ¿verdad? El flujo de operación en planificación de vuelo es bastante similar. Por ejemplo, en el caso de Motion, que es un software bastante amigable, intuitivo, para el desarrollo de una correcta planificación, son muy similares. Y obviamente lo que se desmarca uno de otro es el tipo de aterrizaje. En el caso del IBI con el vientre, ¿verdad? Y en el caso de los Vtol con despegue y aterrizaje vertical.
¿Cuáles serían para ti las limitaciones más importantes de los drones Vtol?
La verdad es que en definitiva, al comparar un equipo de ala fija convencional con un tipo Vtol, son bastante similares. Yo en realidad, cuando hablaría de limitantes más más importantes, ¿no es cierto?, tienen relación cuando uno va a realizar un levantamiento con una topografía muy abrupta, en un sector muy reducido de operación, ¿no es cierto?, en donde por un tema de seguridad operacional uno más bien no utiliza la fija y se inclina más por un multirotor, principalmente por los giros que realiza un equipo tanto Vtol o a la fija convencional.
Claro. Sí, luego tenemos todos los temas de legislación que a veces en Chile, por lo que yo sé, no son de tanto peso, ¿cierto? Y por eso les han permitido, digamos, trabajar un poco más con drones Vtol. Nosotros en Latinoamérica tenemos una experiencia grande en cuanto a temas de legislación y hay otros países que son más rígidos y por eso ahí se torna un poco más grande esa ventaja que tú no estás mencionando, pero es interesante escuchar tu experiencia, por supuesto. Y hace justamente menos de 2 años que comenzamos esta relación comercial con Sensefly. Para mí fue una gran satisfacción tener a Geocom dentro de la familia Sensefly porque bueno, sabemos de la importancia y relevancia que tienen en Chile. Y cuéntame, ¿cuáles fueron quizás las principales razones por las cuales Geocom decidió dar ese gran paso que fue firmar con nosotros un acuerdo comercial y dejar las otras compañías de drones Vtol?
Exacto, mira, una de los beneficios que nosotros encontramos muy importantes en relación a Sensefly, ¿no es cierto? Uno de esos es el tiempo de vuelo extendido del equipo, lo cual facilita y nos permite aumentar la productividad, ¿no es cierto?, de nuestros clientes. El peso, como tú bien dices, de repente, obviamente, tener un equipo mucho más liviano torna una operación segura en el caso de algún incidente, ¿no es cierto? De ser un equipo mucho más livianito,
Claro.
los daños son menores. Bueno, y un punto yo creo que es fundamental de todos es la modularidad del equipo. De repente nos pasaba con otros equipos en donde un cliente, si llegase a tener algún tipo de incidente, los tiempos de espera para la reparación del equipo, ¿no es cierto?, se tornaban muy extensos. En el caso del IBI, al ser un equipo modular, en realidad, ante alguna falla, ¿no es cierto?, identificando bien el problema, bastaba con ir reemplazando ciertos tipos de módulos, ¿no es cierto?, para que el equipo pudiese entrar en operación nuevamente. Yo creo que ese es un punto fundamental.
Claro, perfecto. Sí, sí, se entiende y realmente es un avance muy grande dentro de nuestras plataformas. Y otros problemas que se te ocurran, sean presentes o de futuro para los drones Vtols dentro de lo que es el mercado de drones, ¿cuáles serían si tú tuvieses que pensar en ellos?
O sea, como conversábamos anteriormente, yo creo que una de las principales desventajas podría ser el tema del peso, por la regulación, que hoy en día están mucho más restrictivas los permisos para el uso de sistemas aéreos no tripulados, en donde el peso excesivo de repente puede generar un problema a futuro.
Sí, sí, es muy cierto esto que dices, Oscar, y nosotros tenemos, bueno, en SenseFly equipos de gente dedicados a seguir todo el tema de legislación y regulaciones, porque, como tú dices, en algún momento, más tarde o más temprano, tiene una relevancia significativa. Otra pregunta, quizá la última para ir cerrando. ¿Cuál sería la principal razón que te hace a ti recomendarle a un cliente el uso de un IBX con el sistema lineal de aterrizaje y de lanzamiento frente a un Vtol? ¿Cuál es la gran ventaja que tú dices, mira, ¿sabes por qué tienes que usar un IBX? ¿Por qué sería?
Perfecto, mira, como te comentaba, la mayoría de nuestros clientes prioriza mucho la productividad, sobre todo cuando tienen que realizar levantamientos muy extensos. Y en ese sentido también es una de las grandes potencialidades que tiene el IBX, que es su productividad, con sus baterías de larga duración, lo cual en conjunto con los sensores muy bien desarrollados como la SOA 3D, aumenta mucho la productividad en un vuelo. Entonces, cuando tenemos un cliente que en realidad va a realizar vuelos muy extensos, ¿no es cierto? Y obviamente no va a realizar vuelos en lugares muy estrechos, no tiene ningún problema en utilizar el IBX y
Claro.
contar con todas sus bondades y beneficios que tiene trabajar con ese equipo en términos de productividad.
Sí, es muy interesante, Oscar, que estés usando la palabra productividad y voy a aprovechar de agregar algo que creo que vas a estar de acuerdo. La facilidad de preparación de un vuelo y de tener la posibilidad de hacer varios vuelos durante el día, esa productividad diaria que tiene un IBX frente a otros sistemas, ¿cierto? Porque muchas veces simplemente se comparan brochure con brochure, catálogo con catálogo, ¿cierto? Y quizás todo puede parecer bastante similar, pero cuando vas a campo y la productividad del IBX resulta 2, 3 veces mayor que otros sistemas similares, Vtol, ahí es donde está la gran ventaja. Creo que esa palabra que utilizaste de productividad, cuando la usamos como productividad diaria o por semana, más allá de lo que es un vuelo en sí, es donde tiene más significación, ¿cierto?
Absolutamente, en definitiva, nosotros con el IBX, como te menciono, nos llevamos una grata sorpresa en términos de productividad, porque nos sorprendió mucho. En realidad, yo a modo personal nunca había volado con un equipo de ala fija 1 hora, 1 hora 10. Obviamente uno siempre trata de dejar un
Sí.
rango de seguridad operacional, ¿no es cierto? Pero volar 1 hora, 1 hora 10, yo por lo menos nunca antes había tenido esa experiencia. Por lo tanto, obviamente fue muy sorprendente para nosotros.
Seguro, seguro. Y cuando puedes hacer varios de esos vuelos en un solo día, la productividad es enorme. Así que bueno, Oscar, ha sido un momento muy agradable compartir contigo esta conversación. Esperemos que sea de utilidad para otros usuarios y distribuidores en todo el mundo. Así que bueno, te dejo con un abrazo muy grande, muchos saludos para todos y espero pronto visitarlos.
Perfecto, un abrazo, que estés todo bien por ahí.
Gracias, Oscar.
Hasta luego.
Okay, everyone, so I hope you enjoyed the webinar. So we've had some questions throughout, so thank you to those who did send those. So we'll go through some now. If at any point now during the next few questions there are any more that anyone wants to send, you're still able to do so on the questions tab. So the first question is, we're intending to map in a very windy area. As the EVX is extremely light compared to other drones, how does it handle in the wind? So that's a very good question, especially for operations in the UK and Ireland. So the EVX, considering it's a 1.4 to 1.6 kilo drone, it can handle winds up to 28 miles per hour. So extremely strong winds. And more importantly and critically for landing, when the drone comes into land, as we mentioned for VTOLs, this can completely strip away some of the key selling points in which are claimed when the wind does pick up. And usually when the wind is anything probably over 10 miles per hour, which can happen at any time. Whereas the EBX and the intuitive emotion software chooses the landing direction of the drone, and it uses the wind to safely land flying into the wind. So unlike most drones, the stronger the wind gets, this doesn't actually impact the safety or the accuracy of the landing of the drone. So hopefully that answers that question. Second one is, I've seen a few clients like Sensat do operations in critical areas such as highways and Heathrow Airport, which is true. They've done a project recently in Heathrow Airport. Can Sensafly help in aiding me acquire permissions for more advanced drone operations? So absolutely, as was mentioned in a webinar, we do have in-house experts here which collaborate with not only our end users but our distributors worldwide. They help our users not only in understanding the regulations but also helping acquire sometimes complex EVLOS or BVLOS operations and operations over critical infrastructure such as highways. Richard, correct me if I'm wrong, but our partner Drone Pilot Academy, which help with all the trainers on the EBX, they're actually able to provide the walkthrough for EVLOS operations for the EBX. Is that correct?
Yes, absolutely. They can provide consultancy on that to help users get that accreditation.
Excellent. So that's something that they're well in tune in doing. And Sensafly as a whole, globally speaking, we've had BVLOS approvals in Brazil, Canada, the US, and we're looking to really increase this in 2022. So if you have any projects or you just want some information on potentially how that can be a reality in the UK or wherever you're from, then get in touch with either Richard or myself, and we'll be happy to try and help as best we can. Final question, it's a good one as always. How do we get a demo of the EBX? So Richard, I'd let you field that one.
Yeah, sure. So we've got a couple of locations around the country that we can use for demos. If people want to come to us and have a one-on-one demo, we do occasionally have drone demo days where we'll book a location centrally for people to come and visit us. We can come to you if you can get the relevant permissions to be able to fly at a location of your choice. And finally, we are at the GeoBusiness Show at Excel, 24th and 25th of November, with the EBX on the stand. So please come and visit us there and have a discussion with us how we can help you.
You took the words right out of my mouth there, Richard. I was about to say that as well. So even though the EBX won't be physically flying there, you'll be able to see it. You'll be able to see the emotion software, which is also very impressive to have, and you can even do a kind of demonstration in an area that you envisage using the drone for. I'll be there myself as well, so if you'd like to touch base with Richard or myself during that conference in London, then please don't hesitate to contact us. So after this webinar, we'll be following up with all people who've registered by email, and that coincides with what I said at the beginning. So for those who did stick around, I'm happy to mention that we do have a webinar offer, which is essentially a reduction of around 4,250 euros in value for the purchase of an EBX premium bundle, which is EBX premium camera and RTK PPK. There are limited amount. We've pushed this out. We're doing a blast of these VTOL webinars around the world, so we have a limited amount, globally speaking, around 25. They must be purchased in Q4. So if you are interested, please don't hesitate again to get in touch with Richard or myself. So Richard, any final points from yourself before we close out?
No, just, anybody who has any questions at all, please feel free to contact me directly or via LinkedIn, however you can get hold of me.
Perfect. So Richard, a pleasure as always. Really appreciate the time, and for everyone that attended, it was a pleasure. Hope you found the webinar intuitive and informative, and if you need anything moving forward, don't hesitate to contact Richard or myself. Okay, have a great afternoon. Cheers, Richard.
Cheers, Chris.